water in a medicine dropper, and you squeeze a little drop out. The little drop, hangs onto the end of the medicine dropper. The skin around the water molecules are really sticking together, and it takes a fair amount of weight. You got to get a big enough drop out there for it to break through that skin and begin to flow out of the medicine dropper. On the other hand, ether. We use ether to anesthetize fruit flies for genetic experiments. And in the old-fashioned way, you take a medicine dropper and stick it in a bottle of ether, and then squirt the ether, into a little chamber where the fruit flies were. And you'd think it was a bad technique. Of course, I get kind of a kick out of watching the students do this. You put the medicine dropper in the ether and dribble, ether all the way across the other side. Ether doesn't have hardly any cohesion. The molecules don't stick together at all. And if you suck them up in a medicine dropper and just pull the medicine dropper up, you don't push on it, just pull it up. It just drops right on through. And so it's really hard to transfer it because of that. Well, water is strong enough to do this. And so that's part of God's overall plan. The system wouldn't work if it weren't for the chemical cohesiveness, the stickiness of water molecules. And it only works when you've got dry enough air. Well, what about tropical plants where there's not that much dry air? They actually have to spend energy. Plants living with a sufficiently dry atmosphere, they get water transport for free. All they got to do is keep the membranes alive. They were going to be keeping alive anyway. And water at the top of the redwoods is free. No energy expended in particular to move that water. It's flowing down with energy going. Well, in tropical plants or in Florida plants where the humidity hovers around 100% a lot of the year, they actually have little machines in the membrane, active transport enzymes that specifically use chemical energy to pump the water out. And the water forms little beads, and they're actually little spots on the leaf that pump the water out. Otherwise, the plant would be living in stagnant water. And plants that can't do that can't grow in the tropics. So this decides where plants are going to grow. And so there's a lot involved. And again, it's based on, water going to the top of the tallest tree is flowing down in energy here. Not just, God's capitalizing on chaos, a system designed to harness a natural tendency to achieve a most unnatural, supernatural end. Speaking of end, maybe that, since I did look down at my watch, maybe that's a good idea. Although, I wouldn't want to disappoint you since you came out on the cold night. But this applies to a variety of things. There's another application to plants I won't say anything about. But I think I'll add one more little thing if you don't mind. Now, I guess I talked already about nerve impulses, but this also applies to, see if you can tell me what this is. As soon as I get it right side up. Okay. Hope I don't have this down here what it is. Okay. As soon as you recognize what this is, raise your hand. Available now, linear motor, rugged and dependable, designed, optimized by worldwide field testing. Over an extended period. All models offer the economy of fuel cell type energy conversion and will run on a wide range of commonly available fuels. Low standby power, but can be switched within milliseconds to as much as 1 kilowatt mechanical energy per kilogram of peak dry conditions. A modular construction and wide range of available subunits permit tailor-made solutions to otherwise intractable mechanical problems. Anybody know what we're talking about yet? I see one hand. 1.5, 1 3/4, okay. Choice of 2 control systems. 1, externally triggered mode, versatile general purpose units, digitally controlled by picojoule pulses. Despite low input energy level, very high signal to noise ratio, energy amplification 1 million approximate. Mechanical characteristics for the 1 centimeter module. Maximum speed optional between 0.1 and 100 millimeters per second. Stress generated 2 to 5 times 10 to the minus 5th newtons per meter squared. 2, autonomous mode. Anybody know what we're talking about yet? Or any more people? Made with integral oscillators. It's getting kind of hard to read the glare there. especially suitable for pumping applications. Modules available with frequency and mechanical impedance appropriate for A, solids and slurries, B, liquids, lifetime, 2.6 times 10, or 2.6 billion operations, typical 3.6 billion maximum, independent of frequency. For gases, it can do 50 to 1,000. Many optional extras, built-in servo, length and velocity, where fine control is required, direct piping of oxygen, thermal generation, etc. And it's good to eat. Okay. And now, who knows what that is? What? Who wants to say?
Flagella motor?
That's a good guess, and a flagella motor will be part of this, but this is even more common than that. There's a lot of it in this room. There's an awesome amount of it in front of me right now. Well, maybe not. What were you thinking? It is a cell, but it's a special kind of cell. Requires a lot of mitochondria to make it work. And it's a lot bigger than a bacterial cell. And it's something that can pump fluids or gases, or fluids, gases or liquids, I guess. It's something that can, yes?
A heart.
This is the heart, okay, that's the autonomous mode. Okay, and so what's being described here is a muscle cell. And can you imagine, read this, to an evolutionist and say, how did this happen by chance? Well, you moron, look at all the design and engineering that went into this. Obviously, this didn't happen by chance. And then they get to this, good eat. What's that? And so, this is, just awesome. If you had a factory that could, handcraft and put out these little things on a regular basis, wow. So you can get it to, these pumping, they're autonomous. They have an internal circuit, like the heart beats up to 3.6 billion times, without stopping. That's pretty good. By the way, anybody know which one is for pumping slurries? That's a nice way of saying the digestive system.